Hi, my name is Dwight Dart. I'm the Design Lab Engineer at the University of Virginia, Mechanical and Aerospace Engineering Rapid Prototyping Lab. Here in our Rapid Prototyping Lab, we have 7 fused deposition modeling 3D printers. Fused deposition modeling 3D printing works by taking a spool of ABS plastic. The spool is in a container, and the containers are in the machine. The filaments from the spool feed out the back of the machine down to a print head. The print head is heated to the melting point of the plastic. These build trays start out at the print head, and if you picture any parts that I'll show you, sliced into thin layers, that's how they're manufactured. First cross section is printed with the print head, the platform drops down. The next cross section is printed with the print head, the platform drops down, all the way till you get to the top of the part. Once you get to the top of the part, we extract the tray, take the parts off the tray, and put them in the bath to remove the support material. So here we have a part that has been finished 3D printing. You'll see how easy it is to extract your parts by just opening the door, removing the tray, taking a putty knife, and knocking the part off. This part will have to go into the sodium hydroxide bath, because right now we cannot use it as a wrench. Once it goes through the sodium hydroxide bath, the support material is dissolved away, and again, we can use the wrench with moving parts. We're a very busy lab, so some of the noise you hear in the background is one of our larger projects, printing airplane parts. As here, we also 3D print jet engines. In our jet engine design and manufacturing course sequence, the students get to experience exactly what it would be like to be a new engineer at Rolls-Royce, Boeing, Pratt & Whitney, or GE, or any jet engine manufacturing company. Each student owns a part in this assembly throughout that course. And what they have to do is take their blank CAD of a turbine blade or whatever part they were given in the jet engine, and they have to match it to the new jet engine design that is coming through the course. That's the exact same experience if they were a new engineer at a jet engine manufacturing company.
Well, I'm Josh Raymond. I'm a 4th year mechanical engineer here at UVA, and this is the guitar that we're going to be building. It's a little bit in progress. The neck isn't attached to the body yet, but basically what we did is we built a solid model on the computer of a TI-84 calculator, and then we sent it over to the Rapid Prototyping Lab, and we used the CNC mill to turn our model into something just out of a regular block of wood. So we had to cut the neck and the body independently, and then we'll glue them together later.
I'm Brian Kessel. I'm a 4th year mechanical. After we sent the guitar to the mill, we decided that we were going to print off a 3D printed plastic pickup across in the UVA Rapid Prototyping Lab. So we'll wind this with wire, and it'll be our pickup to pick up the electrical guitar signal.
I mean, it's really cool because you can basically take any ideas that you have, and if you know how to use a solid modeling program, you can put your ideas into the computer, and then you can take them straight out of the computer. It's just like pressing print on Microsoft Word. You type up your essay, you press print, and it comes out. If you build a solid model of basically anything, you can just press print, and out it comes.
The Rapid Prototyping Lab is very handy for building anything that you have an idea for. We went from having a guitar that we had no idea what the pickup was going to look like, and then we decided, oh, let's add some buttons, let's add some neat holes that we can use for some bolts to go through that'll be part of our pickup. It's just very handy to use the Rapid Prototyping Lab.
"3D printing and similar machines are basically at the same place where computers were in the 1980s. Because of computer power nowadays, 3D printers are going to explode into the marketplace just like computers did, but even faster. It will not take 20 years to get a good 3D printer into your home. Just like you have a cell phone, a television, or anything else that a standard person has, a 3D printer will be sitting beside your document printer. And in the future, when you break something, say your window blind or the piece off your radio or a button, something like that, you won't go to Walmart or Radio Shack. You will go to walmart.com or radioshack.com, and just like you download iTunes files, you'll be downloading STL files that you will 3D print at home out of the material you want in the color you want. Wahoo wah!